and go.
Alright, so now we're going to calculate the k sub theta term. We're going to square, since we're going to be squaring it anyway right here, equals so the magnitude of that squared. We're going to differentiate with respect to theta of our position vector. Then we're going to take its magnitude and square. So negative r sine theta sine phi r cosine theta sine phi, and there's no theta terms in the z coordinate, so 0. We're going to square that, square, add them together to get the magnitude squared. It's just 0. We can pull out that factor of r squared sine squared phi, and you just get sine squared plus cos of theta plus cosine squared of theta, which is famously just 1. Sine squared plus cosine squared equals 1. And you're left with r squared sine squared times phi as our k sub theta squared. So that's that term right there. R squared sine squared phi. And then, oh yeah, right there. And for our k sub phi term, squared equals I have to underline stuff. I don't think I did the last one. Retake. I'm just kidding. Alright. Same thing. Negative r. No, r cosine theta cosine phi squared plus r squared sine squared theta cosine squared theta plus r squared sine squared phi. I keep saying that phi in place of theta. Well, those. Hold on a second. I made an error there, my bad. I'm just came off of a 9-hour shift. I'm in 100-degree weather, so if I make a few errors here, my bad. So that'll cancel out and just go to r squared cosine squared of phi, and then you add those, and same thing there. That'll just go to r squared. So in spherical coordinates, our 3D line element dx squared plus dy squared plus dz squared is replaced by dr squared plus r squared d phi squared plus r squared sine squared phi times d theta squared. And that's our spherical coordinates line element. And again, we're working with that because our mass that we're interested in, our source that we're interested in, is spherical. And there we go.